you ever wondered what happens under the hood when you turn the key in your car? Today, we're diving into the fascinating world of car engines. From the moment you start your vehicle, a complex series of events takes place to get you moving. In this video, we'll break down each step, making it easy to understand how your car's engine works. Whether you're a car enthusiast or just curious, you'll gain a new appreciation for the technology that powers your daily commute. Let's start by exploring what an engine actually is and why it's so essential for your car. Its core, an engine is a machine designed to convert fuel into motion. In most cars, this is done using an internal combustion engine. This type of engine burns fuel inside a chamber, creating energy that moves the car. The engine is the heart of your vehicle, responsible for generating the power needed to turn the wheels. Without it, your car would be nothing more than a stationary shell. Now, let's take a closer look at the main parts that make up a typical car engine. Car engine is made up of several important parts working together. The main components include the cylinders, pistons, crankshaft, camshaft valves, and spark plugs. Each part has a specific job, and together they ensure the engine runs smoothly. The cylinders are where the action happens, while the pistons move up and down inside them. The crankshaft converts this movement into rotational energy, and the camshaft controls the opening and closing of the valves. Spark plugs ignite the fuel, starting the whole process. Next, let's see how these parts interact during the engine's operation. Most car engines operate using what's called the four-stroke cycle. This cycle includes four main steps: intake, compression, power, and exhaust. During the intake stroke, the engine draws in a mixture of air and fuel. Next, the compression stroke squeezes this mixture tightly. The power stroke follows, where the spark plug ignites the mixture, causing a small explosion that pushes the piston down. Finally, the exhaust stroke expels the burnt gases. This cycle repeats rapidly, creating the power needed to move your car. Let's break down the first step, the intake stroke. When you start your car, the intake valve opens and the piston moves down inside the cylinder. This creates a vacuum that draws in a mixture of air and fuel from the intake manifold. The precise amount of air and fuel is crucial for efficient combustion. This mixture is then ready for the next stage, where it will be compressed and prepared for ignition. The intake stroke sets the stage for the entire engine process. Next comes the compression stroke. Here, the intake valve closes and the piston moves back up the cylinder. This compresses the air-fuel mixture into a much smaller space, increasing its pressure and temperature. The tighter the mixture is compressed, the more powerful the explosion will be when it's ignited. This step is essential for maximizing the engine's efficiency and power output. With the mixture now compressed, the engine is ready for the next exciting phase, ignition. Power stroke is where the magic happens. At the top of the compression stroke, the spark plug fires, igniting the compressed air-fuel mixture. This causes a rapid expansion of gases, creating a small explosion that forces the piston back down the cylinder. This downward movement is what generates the power to turn the crankshaft, which ultimately moves your car. The power stroke is the main source of energy in the engine cycle. After the power stroke, the engine needs to get rid of the burnt gases. This is where the exhaust stroke comes in. The exhaust valve opens and the piston moves back up the cylinder, pushing the exhaust gases out through the exhaust system. Clearing out these gases is important to make room for a fresh air-fuel mixture in the next cycle. This continuous process keeps your engine running smoothly and efficiently. Crankshaft is a key player in the engine's operation. As the pistons move up and down, the crankshaft converts this linear motion into rotational motion. This rotation is what ultimately turns your car's wheels. The crankshaft is connected to other parts of the drivetrain, transferring the engine's power to the transmission and then to the wheels. Without the crankshaft, all that energy from combustion would go nowhere. Camshaft works alongside the crankshaft to control the opening and closing of the engine's valves. It ensures that the intake and exhaust valves open at the right times during each cycle. The camshaft is driven by the crankshaft, usually through a timing belt or chain. Proper timing is crucial for the engine to run efficiently and avoid damage. The synchronized dance between the camshaft and valves keeps the engine breathing smoothly. Spark plugs are small but mighty components. Their job is to ignite the compressed air-fuel mixture at precisely the right moment. Each cylinder has its own spark plug, and the timing of the spark is controlled by the ignition system. A strong, consistent spark is essential for smooth engine performance and fuel efficiency. If a spark plug fails, the engine can misfire or lose power. Fuel delivery system is responsible for getting the right amount of fuel to the engine. Modern cars use fuel injectors, which spray a fine mist of fuel into the intake manifold or directly into the cylinders. The amount and timing of fuel delivery are controlled by the engine's computer. This system ensures that the engine runs efficiently and produces minimal emissions. The air intake system brings fresh air into the engine, mixing it with fuel for combustion. It includes the air filter, intake manifold, and sometimes a turbocharger or supercharger. Clean air is vital for efficient combustion and engine health. The air filter removes dust and debris, protecting the engine from damage. Some performance cars use forced induction to increase the amount of air entering the engine, boosting power. Once combustion is complete, the exhaust system safely removes the burnt gases from the engine. It includes the exhaust manifold, catalytic converter, muffler, and tailpipe. The catalytic converter reduces harmful emissions, while the muffler quiets the engine noise. A well-designed exhaust system is essential for both performance and environmental protection. Engines have many moving parts that need to work together smoothly. The lubrication system pumps oil throughout the engine, reducing friction and preventing wear. Oil also helps to cool the engine and remove contaminants. Regular oil changes are important to keep the engine running efficiently and extend its lifespan. Engines generate a lot of heat during operation. The cooling system circulates coolant through the engine and radiator to absorb and dissipate this heat. Without proper cooling, the engine could overheat and suffer serious damage. The system includes the radiator, water pump, thermostat, and hoses. Keeping the engine at the right temperature is crucial for performance and longevity. Engine's electrical system powers the ignition, fuel injection, and various sensors. The battery provides the initial power to start the engine, while the alternator generates electricity to keep everything running. Sensors monitor engine performance and send data to the car's computer, which adjusts settings for optimal efficiency and power. Modern engines are managed by an engine control unit, or ECU. This small computer constantly monitors data from sensors and makes real-time adjustments to fuel delivery, ignition timing, and more. The ECU helps the engine run efficiently, reduces emissions, and can even diagnose problems. It's a key part of today's automotive technology. The engine doesn't work alone. Its power is sent to the transmission, which adjusts the amount of power sent to the wheels. The transmission allows your car to change speeds smoothly and efficiently. Whether you drive an automatic or manual, the transmission and engine must work together seamlessly for a comfortable ride. To keep your engine running smoothly, regular maintenance is essential. This includes oil changes, replacing air and fuel filters, checking spark plugs, and monitoring coolant levels. Addressing small issues early can prevent major problems down the road. A well-maintained engine is more reliable, efficient, and lasts longer. Now you know what goes on under the hood every time you drive. The car engine is a marvel of engineering, with countless parts working in harmony to turn fuel into motion. Understanding how your engine works can help you appreciate your vehicle more and take better care of it. Thanks for joining us on this journey through the heart of your car. Safe travels and happy driving.